Okay. Hi, my name is Emily Kondo, and this summer I studied watershed cesspool density and how it influences the abundance of E. coli in Oahu streams. First off, I'd like to thank Papa Jack for providing me with the opportunity to conduct research this summer. Even though I graduated from Iolani this past June, I found myself wanting to do more research this summer, and being able to do so was just such an amazing opportunity, and I'll be forever grateful for it. So I guess I'll start off with the questions we all have when presented with any new information. Why should I care? How does this affect me? Why is this important? And there are two main reasons why we should all care about stream water quality. Number one, many streams feed into the ocean. As you can see from the picture on the left, many of the streams come from the mountains to the sea. And so streams with high bacteria counts can directly lead to high bacteria counts in beaches, and nobody wants high bacteria beaches. Secondly, in this project, I studied the presence of Escherichia coli, better known as E. coli, and if you've heard of E. coli, chances are that you know something about its side effects. Some types of E. coli are associated with problems like diarrhea, abdominal pain, urinary tract infections, and even things like pneumonia and meningitis. So I'll start off with my first question that I had when I started this project. What is a cesspool? A cesspool is a system used to receive and host sewage. Cesspools are generally an older, more outdated way of dealing with sewage waste. They are basically pits lined with cement or stone that allows sewage to seep into the surrounding soil. That sewage has bacteria that can seep into groundwater and thus into our streams. The bacteria could be part of a group called total coliforms, which is a bacteria group that includes both fecal and environmental species. Within total coliforms is fecal coliforms that originate in the feces of animals and humans. Lastly, what I'm looking at is E. coli, which is often used as an indicator bacteria for fecal contamination. In this, I study E. coli because the US FDA recommends it as the indicator bacteria of choice. And an indicator bacteria is a bacteria that's related to the presence of sewage, and it's generally used to evaluate the effectiveness of treatments. Now that you have a little bit of background, let's dive into my project. My research was kind of centered around two main questions. Firstly, what is the source of bacterial contamination in Hawaii streams? And how does cesspool leakage contribute to high levels of bacteria? And so my hypothesis was that bacteria levels in high cesspool density watersheds will be higher than those in low cesspool density watersheds. And in the upper right-hand corner is the map I used to determine cesspool density. To test this hypothesis, I employed two methods: analysis of existing data and experimental testing. So first, I used Surfrider Blue Water Task Force data. So Surfrider Blue Water Task Force is a group that samples approximately 23 sites around the island and tests for the presence of enterococci using collected water samples and IDEX kits. And that's pretty similar to what I did for my project. And this is kind of a map of all the sites they test for on the island. And my second source of existing data was the state of Hawaii, which monitors an extremely large group of sites, and it records bacteria levels and other things like pH and temperature. Okay, so one of my first questions when I started analyzing my data was, do certain beaches have consistently high bacteria counts? And this is kind of an important question for anyone who likes to go to the beach. And my answer after going through my data was yes. As you can see in this graphic, Ainahaina, Chocolates, Kahalu, and Wailupe are amongst the beaches with the highest bacteria counts across the board, with an average of at least 130 CFUs. And To put that into perspective, the safe limit is around 104 CFUs. My next question was, does rain have an impact on bacteria levels? Surfrider actually has their volunteers collect data on the rainfall in the last 3 days from the sampling time. And so I used that data and I found that on average, given rain in the last 3 days, bacteria levels almost double. As you can see here, given no rain in the last 3 days, the average of bacteria amongst all the samples was about 69 CFUs, while with rain, it was around 132 CFUs. And my last question was, does cesspool density in a watershed have an impact on bacteria levels? To investigate this, I used a map of cesspools on Oahu superimposed on a map of watersheds of Oahu to find the relative cesspool density in the watersheds. Using this information, I found that as cesspool density in the watershed increases, so does average bacterial levels at the beaches within that watershed. Using the information I found from the data given to me from these sites, I then decided that I wanted to sample in high and low density cesspool areas. To do so, I chose Manoa Stream to be my high density cesspool stream and Waimea Stream to be my low. At each site, I collected 125 milliliter samples, once at or near the waterfall origin of the stream and 3 times downstream from the waterfall. I also tested for salinity, pH, and dissolved oxygen at each site with similar procedures to that of Blue Water Task Force. Once samples were collected, I used the IDEX call alert testing kits to find values for total coliform and E. coli in each sample. In these pictures, in the picture on the left, you see yellow coloring, and that indicates the presence of total coliform bacteria, while on the right is a fluorescent picture where fluorescence indicates the presence of E. coli. And to kind of figure out how much bacteria from this tray, you use the total number of yellow or fluorescent versus clear to determine the number of bacteria in 100 milliliters. And as you can see here, sites 4 on both locations were taken at or near the waterfall origin of the streams in both the low and high cesspool density watersheds. And in the low, the reading was about 51 CFUs per 100 milliliters versus the high density watershed, which had 5,176 CFUs. And so despite being in similar locations, which if cesspool density did not have any influence on bacteria levels, would kind of reap the same or similar bacteria levels, they're extremely different, kind of furthering my idea that cesspool density has an impact on bacteria levels. Thus, both the existing data compiled by Blue Water Task Force and the state of Hawaii and the data I've collected support my hypothesis that in high cesspool density watersheds, bacteria levels will also be higher. In conclusion, once again, bacteria levels are highest when it has rained in the last 3 days or in high cesspool density watersheds. And I guess the bigger implication of this study is that there are correlations we can use to help predict bacteria levels at beaches. This information could help lead to more accurate predictions of water qualities and warnings that would in turn help beachgoers. Lastly, this makes the idea of cesspool leakage an even bigger issue. If cesspool leakage is influencing recreational water quality, we need to think about what it's doing to everything else. So some things that I would have improved upon for my project include my sample size. Overall, my sample size was on the smaller side, and if given the opportunity, I would have increased the sample size and done more repetitions. This in turn would have allowed me to better draw a relationship between watershed cesspool density and bacteria levels. And I guess now for some advice for next year's fellows. My first piece of advice is follow your interests. This is your summer, so do what you're interested in. It's such an amazing opportunity, so don't squander this summer doing what you think is boring or what you won't be interested in. Second, be flexible. Projects don't always work out how you want them to. Be able to change your plans and ideas accordingly. Don't be disappointed in your results. Even if you're expecting something different, don't let that get in the way of you learning new things. Find out why the results weren't what you expected and learn from it. And lastly, have fun with your summer. This is an opportunity that so few people get, so enjoy it. The ability to gain hands-on experience in the lab, talk to professionals, and learn about what you're truly interested in is a unique experience that many people don't get until college, or even not then. Because of that, enjoy your time in the lab. Well, I know from personal experience that it may not sound glamorous to be spending your time mulling over papers, running tests, and doing lab work while your friends are at the beach or at the mall. You control how your summer goes. It can either be a drag or it can be fun. That's up to you. And I just wanted to end it all off with special thanks to the people who helped me complete my research. Dr. Chan, thank you for your endless amounts of advice, driving me around to sample, and of course, teaching me how to use pivot tables in Excel. Without you, this project would have never gotten off the ground. Mr. Tong, thank you for being willing to come in at odd hours to open the lab so I can grab supplies, drop off samples, and run my tests. And last but not least, thank you to my mom who carted me around the island looking for places to sample and hiked up Waimea Falls Trail with me so I could get my samples. Thank you.